So we have a topic left out, which is like a leftiest tree. Okay, so most of them don't know what is this leftiest tree. Under leftiest tree, now we have like some types. Okay, so like height based leftiest tree. From the height, we'll say height in the sense, right, from one particular node to the upwards till the root node, so that height. And we say like a weight based leftiest tree. So under height based, we have this minimum leftiest and maximum leftiest tree. So let us take an example for you to explain what is leftiest tree. First let me draw and then let me read out the definition. Okay, so this is one tree I will draw here. Sorry, this is A inside. Okay, here I have B, then here I have C, then I have F. Okay, then I have here B also, I mean D and E as a child of my this root. Okay, so now see here, first what we do now, wherever the child is not there, we first fill this with one boxes like this. So D doesn't have both the child, which means it is a leaf node. Okay, like this. Okay, so now see here which node is having two childs, so that will be written 2 like this. Which will have only one child will be written only 1. Okay, and similarly the leaf nodes also will be having simply they themselves will have their own value as 1 here. Okay, so now as you can see here, this is one tree. Let me take another tree here, draw one more tree. Suppose G is the root which has two childs, H and I. Okay, then H in turn is having another child known as J. Now see, again I will say wherever empty is there, I will let me put boxes. Here a box, here a box, then here I have 2 boxes. So according to this, G is having 2 childs, so I will write 2. I here, remaining all will be 1. Unless until a node is having 2 child, it will be 2. If not, only 1 will be written on that. That nothing that, but it's the weight of that particular node. Now see here, let me read out the definition. So a leftiest tree under this height based leftiest tree, also called height based leftiest tree, is a non-empty binary tree that satisfies the condition. What is the condition? So the condition is shortest left child. Okay, or suppose any x denotes the node. Okay, suppose you can write A, B, C, D like that and all. So shortest left child of x should be greater than or equal to same shortest of shortest of right child of that same parent x. Okay, so what see, a tree can be said as leftiest tree when it satisfies a non-empty tree. Okay, it should be non-empty. When it is a non-empty tree and it satisfies the condition, the shortest of a particular parent child, left child, should be greater than the right child. Okay, now see here, and yeah, this condition should be satisfied with all the respective nodes, not just one nodes. So see here, this node over here, it's not a what we say leftiest tree. Okay, this is a non-leftiest tree. Why it is a non-leftiest tree? It is because, as you can see here, let me take the example of this. Okay, this part. Okay, so here this is 0. Okay, it's empty things now. This is be 0 itself, obviously. See here, shortest left child for C here. What is the shortest left child? I will write the shortest left child. Okay, so it is 0. Is it greater than equal to shortest right child 1? Is it true? No. So it does not satisfy the condition. So it is not a left. But whereas this is a leftiest tree. How? You can see here. It should be either greater or equal to, right? Now suppose take G itself. If you take G, so left child is 1. Is it greater than equal to 1? Yeah, correct. If you take H, 1 greater than equal to 0, true. If you take, yeah, here also 0 greater than equal to is there, right? If it is equal also, it's fine. Here also, anyway you take, it is a leftiest tree. Now we will see what is now the minimum leftiest tree. Okay, so this is about the height by just basic like one overcap or review on your leftiest tree. Now we have minimum leftiest tree. Minimum leftiest tree, how you define? So you have to say minimum leftiest tree is also a leftiest tree in which each key value in each node is less than their children. Okay, what does this mean? Suppose let me take one example. I'll draw this same, but I'll draw empty. Okay, first let me draw an empty without any values. Let me draw. Okay, so here, see here, and here let me put like this. Okay, this part is visible, right? Now I'll fill wherever child is not there, I'll put these boxes. Okay, here I will having this. So now what the definition says, so each key value should be greater than its parent child, or else each key value should be greater than their children. Okay, so how we say this? Now let us see. Now don't get confused. So let me write. So see, suppose my root is 2 here. Okay, so the child of this should be greater. Okay, the key value of the children should be greater than this. So here I will write like this 11 and suppose 13. So this is the same example which is asked in the model question paper. Okay, now see here, don't see the values. Okay, see here 7 is greater than 50. No, 7 is less than 50. It is not left. You say, hey, what man? So here what you have to see, you have to see the weight. It has both the child, na? So this weight will be 2. So it has only one child. If it has only 2 child only, the weight will be 1 1 1. Here also 1 1. See, 1 is greater than equal to 1. True, right? So it is a leftiest tree. What minimum leftiest tree means? What value should decrease from the root? If it is coming down, it should decrease. Okay, I mean increase, the value should be increasing from the root until the bottommost level, that is not your leaf node level. Okay, so this is your minimum leftiest tree. Similarly, the ulta of this also I can take one example. Okay, let me first draw an empty tree, then let me fill the values. So here let me take another child. So here similar same tree thing. So what I will do, I will just change the values to show it is the this minimum. This is max. Okay, mx max leftiest tree. So suppose here 30 is there. So here should be 20 and 10. See, it's decreasing. So here 30. You can write 8 9 7 6 also. Here I will write 8 4 and 2. Okay, so here this weight is 2 1 1 1 1 everywhere 1. Understood? So this is what you have to know about your minimum leftiest tree. Okay, so one question was asked in the what to say. Okay, if you want to know, let us also talk about weight based leftiest tree. Weight based leftiest tree is nothing but here we will be considering the weight. Okay, so here nothing but the another kind of leftiest tree, the definition let me read out. We consider the number of nodes in the subtree. Okay, how many number of subtrees are there in a particular row, rather than the length of the shortest route to the external node path. This is nothing but our weight based leftiest tree. So let us define the weight of a particular node. So how do we define a particular? So what is the definition? You will see how many number of subtrees does a tree is having, rather than seeing the distance from a particular node to the root node. Okay. So now how this is explained. So see here, weight of particular node is defined by weight of this left child plus right child plus 1. Okay, so let me see if this pen works. I will explain here. So now see here, weight of suppose 4. Okay, what is weight of 4? So left we have 1 left child weight plus here right child weight. Okay, right child weight. So right child, say child. Now here what is the value of right child? That is 0. Then plus 1 I say. Okay. So the weight of this particular fourth node 4 ka weight how much? 1 plus 0 plus 1 nothing but 2. So this is how you determine the weight. So just add your what is the value weight of this left child plus right child plus 1. So for 30 if you see left child ka weight is 1, right child ka weight is 1. So 1 plus 1 again plus 1 you have to write. Okay, so let me now let us solve that particular problem which was asked in the what you say the question paper. So they say melding a tree. So what is the meaning of melding a leftiest tree? Nothing but we here also we add 2 trees. Okay, we combine 2 trees, but one thing we have to make sure the property we make sure the property still satisfies that minimum leftiest tree. So from root nodes is the minimum. So from that we go for the increasing order. Okay, so let me just pause and write the question first. So I wrote that given question where they have asked us to meld this particular thing. So now you can see here, first check whether it is like properly a proper leftiest tree or not. So both are proper leftiest tree. Now what here we have to do is just see here. So here we have 2, 7, 11, 13. So this like this you see, each line going like this. So 5, 15, 80 correct. So here this correctly it's going like this. And now you see here the right thing of this now, it's all general you have to do. You have to simply make the, so how we combine two trees, this second tree will be the right child of this first tree root node. But here one thing what to do, if you put 5 here na at this place, so see 50 is greater than 5, so that cannot be happening. So what you have to do here, this thing this will be breaked and this will put here, and you will check if that condition satisfies. So let us do that. 2, 7, 11, 13. Okay, now what I said, I will make this as my right child, this tree as my right child. 9, 12, 20. Okay, so here I have 18, it is still correct. If I put here same tree, if I write 8 correct, here 10 correct, and here 15 right, it's still correct. Okay, so it's correct itself. Now remaining part, this dissected part, so this I can see where I can join. So obviously here I have to see and join it. So wherever the boxes are there, you have to place one empty boxes, just do like this, and you have to write one each place. So which is having two children properly, that I will show how that. So here I have one empty box. Yeah, here also there will come one. Yeah, anything left? Yeah, 10 here. Okay, so see here, this will be having 2 weight. This is having 2 child na, so this also will be 2. So this 8 is having 2 child, 2. Now 10 is not having 2 childs. Here 1, 1. So 12 is having 2 childs, but 9 is having only 1 child. This will be 1, 1, 1, 1, 1. So like this you write and just melt the given tree. Now see here, if they ask suppose for same question somewhere, suppose here now if I put here 6 value, okay, here 6 was there. So they will give show, or they will ask you to define the leftiest tree. I explained whatever the leftiest tree are, and they will say whether justify whether it is leftiest tree or not. So how you will say, if what kind of leftiest tree they have asked. If it is minimum, you have to say all the values after the root node, the each child node will have the greater value, key value, than its parent node. Okay, simple words you can write like this. And if the given tree satisfies, you will just say the given tree satisfies the properties of a leftiest tree, hence it is a leftiest tree. Suppose it doesn't find, so you have to mention like that. So like suppose 12 children, so suppose here 13, 6 was there, so the left child of 11 is 6, which does not satisfy the property of leftiest child, where the child node of 11 should have the greater value, key value, than its parent node. Like that we can say and conclude your answer. So this is all you have to know about your leftiest tree.